Hello everyone, welcome back to ptet.chemistry channel. My name is Dr. Odd. In this tutorial video, we'll go through this AQA topical series. This is AQA A-level chemistry. We'll go through this energetics topic. In this first question, so propanol can be formed. So propanol is this CH3COCH3 and glucose is this C6H12O6. So we're just going to balance the equation for that 1 mark. So looking at the equations, the easiest to balance, there are 6 carbons. And there are 3 carbon there, and there is 1 carbon there. So it cannot be 2 here, because if it is 2, then there will be no more carbon left there if this is 1. So the easiest thing to balance is always start from the complicated one and make it 1. So there are 6 carbons. Can't be 2 because 2 times 3 is 6, and I must have 1 carbon there. So this must be 1. And if there are 3 carbon there, but there are 6 carbon we started from, so there must be 3 carbon left over. And having done that, I would have found it easier to do the oxygen, I think. So there is 6 oxygen, but there is 1, which means I have messed up. So it can't be correct as well because there seem to be too many oxygen. So the easiest thing probably is make it into 2. And if there is 2 there, so there is 12 carbon to play with. And if I have 2 there, that would be 6 carbon to play with. Then I have 6 carbon. Not as easy as I think it should be. So there is 2 oxygen and 12 oxygen. Oh, why is it like that? So maybe it's not 6 there. Maybe it's 3 of these, because my carbon keep on coming up a little bit short there. Let's see what's going on. So there's 3 carbon times 3 is 9. And there's 12, so there must be 3 there. But I have 6 oxygen. I have 3 oxygen, so now this seems to be alright because 6 plus 3 is 9. I have 12 oxygen there on the left. So this means that I'm left with 3 more oxygen from the H2O. Let's just count the hydrogen. 3 times 2 is 6 hydrogen. 3 plus 3 is 6. 6 times 3 is 18. 18 plus 6 is 24 there. 12 times 2 is 24, so this equation is balanced now. Now deduce the role of bacteria. So you will see that come into contact with bacteria, but bacteria doesn't appear on the left or on the right. So bacteria is something which is a condition. So bacteria is acting as your biological catalyst, because bacteria will provide you the organisms that actually have enzymes, and therefore this is via the enzymatic reactions involving bacteria that they act as biological catalysts to speed up the rate of chemical reaction here. In part B, so you will have learned about the square bracket oxygen. You count as oxygen atoms because oxidizing agent itself will get reduced, but it will help the other substance to be oxidized. In organic chemistry, we talk about the other substance gaining oxygen atoms. So if we are oxidizing propan-2-ol, as you will know from the naming, we have got CH3, C, and then CH3. We have a H, we have an OH there. So I will have CH3, CHOH, CH3. And this will go to propanol, as this is a secondary alcohol. Secondary alcohol means the carbon with the OH is bonded to 2 other carbon. That's why we call this secondary alcohol. More of this in the AS alcohol topic there. And it will form this propanol, which is CH3COCH3. So actually, to balance this kind of equation, it's a lot easier for you to use molecular formula. Total up the number of atoms. 3 carbons, 3, 4, 5, and 8, and then 1 oxygen. This is 3 carbons, 6 oxygen, 6 hydrogen and 1 oxygen. As you can see from the molecular formula, the number of oxygen is still the same, but then what can I say here? You have lost the hydrogen instead. So when you react with that, where does the extra hydrogen go to? They will go to H2O. And if you form H2O, you've got 1 oxygen, 2 oxygen. You got 1 oxygen, 2 oxygen. So you do need the oxygen from the oxidizing agent there. And that will give you your other oxygen. 1 plus 1 is 2 oxygen. 1 plus 1 is 2 oxygen. 2 hydrogen plus 6 is 8 hydrogen. 8 hydrogen on the left, 8 hydrogen on the right. Balance equation there. Next part was something I've mentioned already. the carbon with the OH is bonded to two other carbons. So that means this is a secondary alcohol. So they already told you it's alcohol. They just haven't told you there's secondary alcohol there. This part C is more like the energetics level kind of question. How many marks is this? This is a 3-marker question. So this student determine a value for the enthalpy change when you burn the propanol. So enthalpy change when you burn something in excess oxygen, this is very much likely like enthalpy change of combustion. So what we have is we are warming up some water. So this is your H2O. And then you are burning, instead of petrol, you are burning the propanol. And enthalpy of combustion when you burn something in excess oxygen is always exothermic. So every single combustion will give you an exothermic reaction. What we are doing is we are heating up the water. So this is the mass of water. The temperature change, this is the delta T in degrees Celsius, which is equal to the delta T in Kelvin. That's the number one mistake that a lot of students make, because imagine when you have 0 degrees Celsius, there will be 273 Kelvin. And imagine now when you have 25 degrees or 20 degrees Celsius, make our life easy. And now this will be 293 because it's 273 plus 20. So this is the change in temperature for degrees Celsius. So that's 20 minus 0, that's 20 degrees Celsius. But when I talk about change in temperature for Kelvin, that is also in Kelvin. There's also 293 minus 273. There's also 20 Kelvin. So be aware that when we talk about change in temperature, it's the final minus the initial. Change in temperature in degrees Celsius is the change in temperature in Kelvin. There is no difference whatsoever there. And you burn this much mole of pure propanol. So that is from the bottom reaction. But you are heating up the water. You have a thermometer inserted in the water. So you're measuring the heat change of the water. So that's essentially what you're doing there. Use the student results to calculate a value in kilojoule per mole, because that is for 1 mole of propanol there. We're given heat capacity of water. This is the energy required to raise the mass, to raise the temperature of 1 gram of water by 1 Kelvin. So the first thing I can do is Q, which is heat energy. So this is heat energy. Q is equal to M times C delta T. Do not ever put in the mass of solid or anything. It has got to be the mass of the water, because we are using the heat capacity of water. So we are just changing the temperature of the water. So that's 4.18 joule per Kelvin per gram. And this is change in temperature in degrees Celsius. It's the same in Kelvin, so it's 8.0 Kelvin. And you can see the per Kelvin and Kelvin cancel, gram and gram cancel. So just pressing your calculator and you should get the heat energy. Follow the units very, very carefully and you should get 5016. This is in joule. But what do they want us to do? They want enthalpy change. Enthalpy change has sign, it has value, and it has unit. So the sign there is going to be exothermic, because the temperature increase by that however much that one is. So I'm going to put negative. I'm going to convert the joule into kilojoule. Convert the joule into kilojoule by dividing by 1000. The whole thing has to be divided by the number of mole. This is the mole of the pure propanol, because you didn't burn 1 mole of propanol, you burned 4.50 times 10 to the minus 3. Overall, you can see I have a negative sign there to represent enthalpy change. So I have kilojoule on the top now, divided by 4.50 times 10 to the minus 3. I get 4.7. But then looking at the data in the question, it was 2 significant figures. It was 3 significant figures there. It was 3 significant figure. 3 significant figure for the 4.18. Majority of the data is in 3 significant figure. I will give my final answer to 3 significant figures. So minus 1110 kilojoule per mole. But before I run out my answer, I always try to show whatever I try to estimate before I run it up, essentially, like the previous step. This next part is defining this term here. So there is a standard condition, there is the combustion there. So it is referring to the enthalpy change. So a 3-marker definition here. enthalpy change when 1 mole of a substance, so the value above there was kilojoule per mole, it was for the propanol, and this one has to be burned completely in excess oxygen. So that is your first point here, in excess oxygen. And then burns completely in excess oxygen, everything in standard state. So everything on the left and on the right must be in their standard states. And the next bit is under standard conditions. Seems a bit repetitive, but standard states there is under standard conditions. The standard conditions is a plural thing, 298 Kelvin, or you can choose to use 25 degrees Celsius, and also 1 atmospheric pressure, 1 atm pressure. And that's it for that 3 marks definition there. In part E, we're supposed to use this mean bond enthalpy data in the table, and we want to calculate a value when gaseous propanol is burnt. The term gaseous there is very important because bond energy calculation, hang on, what's going on? Bond energy calculation only works when everything's in the gaseous state. So defined bond enthalpy is the energy required to break 1 mole of the covalent bond. Now everything must be in the gaseous state, and which is why we did not burn liquid propanol, we burn gaseous propanol here. So that means we can use the bond energy for our calculation. Gas, 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 and gas. The first thing you should do is draw and see and count the number of bonds, because if you don't draw it out, then you would be very mistaken about the number of covalent bond. So there are 4 times the oxygen double covalent bond, so just be very careful there. And carbon dioxide, there are CO2, so 2 of them in 1 molecule, but I do have 3 of that CO2, just like I have 4 of the oxygen molecule, and I also have 3 of the water molecule, so OH2, there's H2O there, 3 of them. So be very careful. So we're going to look at the total energy for bond breaking. So for bond breaking, what are our bonds to break? We have CH3, we have CH, 1, 2, 3, 4, 5, 6. So 6 times CH plus CC and CC, so 2 times C and C. We also have 1 times C double bond O. Hang on, 1 times C double bond O. And we got 4 times oxygen double covalent bond there. So looking at the data in the table, so 6 times CH, so 6 times 4, 1, 2, plus 2 times CC single bond, so 2 times 3, 4, 8, plus 1 times C double bond O, so 805, plus 4 times oxygen double covalent bond, I get 5957. This is kilojoule per mole. Now, after doing the total energy for bond breaking, that's on the left side. Now I do the total energy for bond forming or bond making. This is on the left. On the left, just now was that bond breaking. On the right, then we form the bonds. There is CO and CO, 2 of them in 1 molecule. So when you have 3 of them, this is going to be 3 times 2 times the CO covalent bond. You also need to add 3 times 2 because there are 3 molecules. In 1 molecule, there are 2 covalent bonds. There's the OH there, so 2 times OH there. It's going to be 6 times C double bond O, so 6 times 805 plus 6 times OH, so plus 6 times 463 there, 7608 is my total energy release when I form the bond there. So what I'm going to get is the enthalpy change is the total energy for bond breaking, 5957, and then minus the total energy for bond forming. And without doing any calculation, you can see it's small minus big. I'm going to get a negative value, minus 1651, signed value, and also unit there. In part F, the last part of this really long question actually, suggest 2 reasons why this value calculated in part C is different from this part E. So part E was from bond energy calculations, and it was mean bond energy. I must highlight on the word mean bond enthalpy, and in part C it was enthalpy of combustion experiment. So in these kind of experiments where we burn the propanons, liquid propanon by the way, if you look at the stat symbol earlier, and we have a lot of possible heat loss. And heat loss would mean not all the energy from the burning of propanon goes into heating the water, and therefore this value -1110 is clearly very different from -1651. So we can say that, what can I say? So in part C experiment has a lot of potential, has a lot of heat energy loss to the surrounding, as you did not insulate the experimental setup, and therefore not all the energy, so not all the heat energy get transferred or goes to heat up the water. Now, how about another reason? That was just looking on that not being very accurate there. But if we look at these, one of the first things you should notice is this is a gas, whereas previously in our equation we were looking at a liquid. I think we're looking at a liquid propanon. So liquid propanon there. So we don't burn the gas, we burn the liquid propanon. And therefore this gaseous state there is significantly going to affect the story there. So propanon is a liquid at room temperature and pressure. Why do I talk about room temperature and pressure? Because there's under standard conditions. So room temperature and pressure under standard conditions. So if we want it to be enthalpy, standard enthalpy change of combustion, so that means that in part E, the propanon is gas, the propanon is gaseous, so therefore not really defining or not really giving the appropriate value for the enthalpy of combustion, which we did define earlier as everything in the standard state there. And that's it really overall for that 15 marks question. Let me see quickly what is the thing there. So I think question 2 looks a bit long, so I'll probably just leave it there for these particular short tutorials on energetics, and I'll continue more in the next topical tutorials, continuation of energetics next time. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Twitter, Telegram, and other platforms to get connected. So don't forget to get in touch if you're interested in highly personalized and effective private one-on-one tutoring. Thank you for watching. See you in the next tutorial video.